today we're going to contrast return on investment with net present value and internal rate of return and go through the calculations. All right, return on investment. This is the profit that you make above and beyond the initial investment that you got. It is a calculation that covers the whole project life. No telling how long it's going to take to make that return. What if I guaranteed you 25% and it would take 40 years to get it? That's a long time to wait for 25% return. You'd be better off earning 1% per year in a savings account, because then at least you'd have 40% when you were done. So you have to be a little bit wary of return on investment. How long did it take you to get that? So return on investment has a little bit of a flaw. What we really would like is a measure that gives us an annualized rate of return, because that's what we're used to seeing with interest rates and other projects that we may want to compare it to. So an annualized measure is a better common measure to use that's interchangeable with other things, better comparison point. We can get this by doing IRR in Excel. You can't calculate it manually very easily. All right, so open up Excel on another screen, put this data in, and let's learn how to do it. All right, first, return on investment. Well, you can do that manually if you like. That's the returns less the initial investment over the initial investment. 57.5%, pretty nice looking, except it took you 7 years to get it, so you know you're not earning 57% per year. What are you earning on average per year? All right, we're going to calculate IRR in that yellow cell. So toggle over to Excel, and here are two screens to walk you through it. Okay, 12.8%. Not a bad annual return, but is it enough? Cost of capital is 14%. All right, let's look at net present value. Net present value is not a percent. It is a dollar amount. It is the dollars earned above cost of capital. What do you guess it's going to be here? Did we earn enough to be above cost of capital? We didn't, did we? All right, freeze this frame, use these instructions, go calculate NPV in Excel. All right, did you expect it to be negative? Yes, because you didn't earn cost of capital or the minimum return, which may even be greater than cost of capital. All right, do another one. Pause the screen while you go over to Excel, put in this data, see how far you can get, and guess at net present value. All right, return on investment, add up your flows, subtract the initial investment, and then divide by the initial investment. 30.4%, but only 7.7% annually. And you do expect a negative net present value because you're not earning anywhere near that 14%. So you should be able to predict your net present value. If you're comparing to what you get with the tables, you'll be off a little bit because Excel doesn't round and tables are rounded. Try another one. Okay, 72% project return, nice. 17.7% annualized return, looking pretty good. Will net present value be positive? It will, because you're earning more than your cost of capital or your minimum return, and so you get a positive net present value. All right, let's move away from Excel and let's go analytical. Take a guess, positive, negative, or zero net present value. That's right. If you're earning more than the cost of capital, net present value is positive. Less, it's negative. If it's exact, then net present value will be zero. All right. Guess how long the project is going to last. Less than a year, or more than a year? What do you think? If you're earning 50% per year and the project's only earning 10%, you can do it 5 times a year, right? To get that 50%. Or the project is 11% and it's 5% per year, it probably took you more like 2 years, or at least over a year to earn it. And for the last one, you're earning 8% a year, the project earns 8%, the project must be exactly a year long. Let's try another one. Guess these yellow boxes: positive, negative, or zero net present value, and how long is the time frame of the project? Freeze the frame while you're thinking. That's right. First one's going to be positive, second one's going to be negative, last one's going to be zero. Assuming an 8% cost of capital.